Happy Thursday, everybody. Today we are going to continue talking about forces, but more specifically today we're going to be talking about net forces. Go ahead and read the following question and answer it in 1 to 2 complete sentences on your worksheet. You observe or see your science textbook sitting on your desk. What forces are acting on your book even though it is not in motion? It is not moving. So think about the types of non-contact and contact forces we talked about yesterday and the day before. How would you answer this question in your own words? 2 minutes, go ahead. All right. So, if we're looking at the types of forces that are acting on our book, first let's think about what is actually keeping it down. What's keeping it from not just floating out and about up into the air? Ooh, let me change that actually. If you said gravity, you are absolutely correct. The gravity, remember, or the gravitational force that we learned, is the force that's pushing down on our book, keeping it in place on our desk. But then what's the force that's keeping it from going all the way through the desk and down, 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 down? That's going in the opposite direction. If you said normal force, give yourself a round of applause. Good. So you see that both of these forces are acting against each other. So ultimately, our book is not in motion. Hey everybody, what's our date today? March 26th, 2020. We are talking about net forces today, net force. Once again, we are still on that 6th grade standard. Investigate and describe that an unbalanced force acting on an object changes its speed or direction of motion, or both. So your goal is you will be able to describe the effects that forces have on an object's motion. So the effects of forces on the motion. So we're going to be talking about balanced forces, unbalanced forces, net force, motion, speed, and direction. Our essential question, how can you calculate the net force of an object when there are different parallel, think about parallel, they're going side by side in opposite directions. Parallel forces acting on it. Okay, and our check for understanding is going to be a 3-question exit ticket, which you can find under assignments. Alright, so our net forces is a total of all forces acting on an object. It is measured in the unit of newtons. So if you ever see a problem talking about force, you're going to know its force by the capital N next to it. So if the net force is 0, the forces are balanced and the object is holding still. It's not moving. It's staying put. Right? That's kind of how we saw our desk was staying put. The gravitational force and the normal force were canceling out. Those were considered to be balanced forces. If the net force is not 0, the forces are unbalanced and the object would be in motion. So we see an example of that here. Right? It's moving 18 newtons, again that's our unit of force, to the left and 20 newtons to the right. So our net force, if we subtract the 2, is going to be 2 newtons. Okay, so once again, our balanced forces are when 2 or more forces are acting on an object are equal in all directions. So notice here, what is the force being pulled in this tug of war game to the left? 300 newtons. And to the right? Also 300 newtons. So ultimately, they have equal strength on both sides. So there's not going to be any motion. In comparison, we have our unbalanced forces. This is when 2 or more are unequal forces act on an object. So this is going to result in the object moving in the direction with more force. So in this tug of war game now, on our team on the left is pulling with a force of 400 newtons, whereas our team on the right is pulling with a force of 300 newtons. So go ahead and pause it, see if you can come up with the net force. Okay, if we do 400 newtons minus 300 newtons, that gives us a difference of 100 newtons. And that is our net force. Let's look at a few examples. This is our first one, and you're going to be answering these on your worksheet. Which direction will the soccer ball go? What will be the net force? Take 10 seconds to work this out. Come up with your answers. All right, if you need more time, just go ahead and pause it. So when you're looking at a problem like this, you always want to start by seeing which forces and what direction they are moving in. So on the left, we have a force of 75 newtons moving to the right. On the right, we have a force of 125 newtons moving to the left. So where's more force? It's got to be here. So which direction is our soccer ball going to go? To the left. If you got that, round of applause. So now how can we calculate our net force? So we're always going to take our larger force, 125 newtons, and subtract the smaller force, 75 newtons. So what do we get? We get a 0. Make that a 12. That crosses out. 12 minus 7 is what? 50 newtons would be our net force. All right, example 2. What is the net force on the airplane? So this one is a little bit more involved. The airplane is moving with a force of 800 newtons. However, there are now 2 forces moving in the opposite direction on the airplane. Go ahead and pause the video, take your time, see if you can come up with an answer for the net force, and then press play when you're ready and you can check your work. All right, so when we're looking at this one, the first step we are going to take is we are going to add the forces that are going in the same direction. We're always going to do that. So that is our 60 newtons of wind force and our 40 newtons of air friction. Those are moving both in what direction? To the left. So we have a total of 100 newtons moving to the left. The second step we're going to do is now what we're used to. We're going to subtract the smaller number from the larger. So the larger number was the force of the engine of 800 newtons, and we're going to subtract that 100 newtons that we found, which was the sum of the forces going in the opposite direction. And what does that give us? 700 newtons. So our net force is going to be 700 newtons. And we can rephrase that and say the airplane will move with a force of 700 newtons as a result of air friction and wind. So those were the two forces that were working against it. All right, so after that second example, now that brings us to page 3. And I want to bring your attention back to that simulator that you may or may not have gotten to yesterday in yesterday's classwork. So looking at this forces simulator from yesterday, complete the table below in order to find the net force for each of these scenarios. So you can either use a simulator and set up these different scenarios on your own and then fill in the table, or see if you can predict these values before even clicking on the simulator as an extra challenge. Okay, so once you're ready, go ahead and click on that link, and it's going to bring you to the simulator. You're clicking on net force. So now you're going to set it up like you saw in the table. So I'm going to add the medium-sized blue over here and the smaller red over here. And go ahead and click values. You can see right here the forces that are being put on the cart by the two different people. So we have 100 newtons being pulled from the left and 50 newtons being pulled from the right. Who do you predict is going to win? Looks like blue has it. Okay. And then if you click on sum of forces up here, that's essentially the same thing as net force. And you might have figured it out yourself. So sum of forces is 50 newtons. So go ahead and do that for the rest of the 4 rows and come up with a complete table. Okay, so when we're talking about force, we also have to think about what the consequences might be in it changing the speed and or the direction of motion of certain objects. So I want you to think about this question. And you're going to answer this in your worksheet. When two people collide in football, would their speed or direction of motion change? So using this little GIF over here, let's wait for it. So they're running, boom! They hit each other and fall to the ground. How would you answer that question? So again, if you're thinking about their speed and their direction, if you said both, you are absolutely correct, right? So if they are hitting each other, that's what we call a collision. Notice they're running, and then all of a sudden they slow down almost to a complete stop, right? They fall to the floor. And we are changing the direction. So speed is going down and direction is changing as well. So this is going to be an important concept for our lesson tomorrow when we start talking about acceleration, and the relationship between distance and time. So keep this in mind. All right, y'all. So now that you have finished the lesson and filled out your guided notes, go ahead and scroll down to page 4, and you're going to be completing the independent practice problem. So you're calculating the net force for each of the following blocks and also deciding which direction the blocks are moving. So you can just type it straight in here. So maybe I would say it's moving 5 newtons to the right. I am not saying if that is right or wrong. That is up for you to think about and figure out yourself. So go ahead and do those problems, and then there are a few word problems as well. Number 14 is a little bit more challenging, so think about that one a little bit longer, but these ones should not be too difficult. If you have questions, I'm here to ask. Just ask in our video chat. All right? All right, we made it. Last thing, y'all, once you have completed today's lesson and the practice problems, go ahead and navigate back to the assignments tab in Teams and then just knock out that exit ticket. Should not be too hard. All right, great job today, y'all.